Oh. Okay, we are live.
Wherever you are in the world. And a special hello to some of our younger viewers watching today: Fraser, Caitlin, Devin, Arlo, Spencer, Matthew, Mason, Luke, Christopher, Nicholas, Alex, Miles, Chloe, and to all of our friends. Today we are celebrating ROV SuBastian's 4th birthday. And if you haven't had a chance to see this incredible underwater robot, you are about to over the next 30 minutes. Sebastian has gone to places no human has seen, discovering record-breaking creatures, and there are a lot of exciting stories to tell. If you have questions during the next 30 minutes, please submit them via Facebook or YouTube, as we have our wonderful Nick Bingham, electrical engineer, answering questions live. On this day 4 years ago, ROV SuBastian was put in the water for the first time at the Monterey Bay Research Aquarium Institute's testing facility in California. Following these first tank tests, Sebastian touched the waters in Guam for the first time in the ocean. You may be wondering what exactly an ROV is, why are we celebrating a robot, and what it has done. Well, stand by, because we are going to dive into these questions today. I am pleased to be joined by Russ Cofield, lead ROV supervisor, a highly skilled ROV pilot, and Jason Williams, our lead mechanical engineer, who will remotely connect from his workshop. Let's travel to Queensland, Australia, where research vessel Falkor is currently anchored. For those of you who do not follow us often, we just finished an outstanding expedition exploring the Ningaloo Canyons with Dr. Wilson from the Western Australia.
Yeah. Yes. Hello, everyone. Welcome to Falkor, and this is here's Sebastian. So, Sebastian's an underwater vehicle, commonly called an ROV, which is a remote operated vehicle. So, when we look at Sebastian, you think that's a large object to go in the water. How does it float? Well, if you look on the top of the vehicle, you can see there's a large yellow block. What this actually is, it's a flotation block. This actually allows the vehicle to remain in a neutral position in the water. And then you think, well, how does Sebastian move around in the water? So Sebastian itself has what's called thrusters on it. I've actually got one here to show you. It's slightly easier. This thruster here allows the water to be pushed through, a bit like a propeller on a boat. This allows Sebastian, it's got 5 of these thrusters available on it. This actually allows us to drive it around and descend to the very depths of oceans for all these beautiful creatures I find in all these dives. So another really interesting thing about Sebastian is, of course, it's designed primarily for a science operations. So it's a slightly different configuration to a normal ROV. When you look at the front of the vehicle, you think, wow, there's lots and lots of things on here. So if we look up top on this rail here, we can see there's a multitude of different sensors. The first thing that really stands out is the amount of light we have. We have 360,000 lumens worth of light, which is kind of the equivalent to like 150 car high beam lights. A lot of light. And that lights up our work area and the seabed so we can see all the beautiful creatures. We also have things like a sonar, so that allows us to see objects such as a cliff or rocks, any features that we would like to go and look at. We also have these really, really beautiful cameras. Now this camera is the main camera. This is a 4K camera. So this actually allows us to transmit 4K video, the very, very high quality video, Facebook and obviously YouTube, etc. Basically what you guys are looking at home, camera that provides that for you. This other camera here is the pilot camera. This allows the pilots to fly, move the camera around and disturb the beautiful views that you're getting. You'll also notice arms that are up front here. These arms are what we would use to take samples. So when we're actually down at depth, we have the scientists give us different tests to do. So we might want to take, say for example, a push core. The arm will actually take this device and it will use it, take a sample in the seabed, remove it, and then this will be placed back into its quiver, so scientists can later determine what's inside the soil. We also have an underwater vacuum cleaner, as we call it. It's a suction sampler. This over here, which is this little hose. What we can do is we can actually suck up samples to get placed in these jars. Actually, there's 8 individual jars, so there's. We also have these boxes in the front here. Now, these boxes are generally divided into segments, so you can take things like rocks, or we can take other wildlife, and then they can be divided up into separate segments. And obviously, when we're finished, the lid can close, seals the samples in place. We also notice this tray here that the boxes are on, this can actually move in and out of the vehicle. So this allows us to actually retract it back, keep it out the video footage, so we don't actually disturb all the beautiful video that we're bringing in to the shore side. Above the vehicle, you'll notice there's a large blue object. This here is a docking head. What happens is, when we go to launch Sebastian, it's actually attached to the ship by a big long cable. Just think of it like a large extension cord, some armoring on the outside to take the weight. What this does is it allows us to transmit the power down to Sebastian to run the pumps and the hydraulics. It also allows us to transmit the data back to the fiber optics. So it's like little fibers with the data coming traveling through it. So what we do then is we can actually lift Sebastian up off the deck, next into the docking head. You can see the long cable right along the top there. So this is actually like an umbilical cord, a bit like a baby and a mother idea. And this actually goes up to the big winch. Coming around into view now. This here would actually have all the cable on board. This has over 5,000 meters of cable on it. And our vehicle actually generally works between 4,500 meters up to about 100 meters. That's generally we work safely. On the actual umbilical itself, we actually attach these. These are called lemon floats. What this does, this actually allows us to have what we call a catenary, or like a buffer zone, so that we can actually make sure that the umbilical is kept reasonably slack behind the vehicle, so it doesn't actually get caught up or move the vehicle around too much. Attach these on as we deploy it over the side. And back to you, Carly. So one of the unique things about the Smith Ocean Institute is we have an Artist at Sea program. We actually bring an artist out during these missions that we take offshore, and they get inspiration to do some designs. So we had actually had a thought that why not, let's put some designs on Sebastian. So what we've done is we've actually, over the years, we've actually had artists print these plates. We actually put them on the ROV. This one's actually from Bailey Ferguson, who was inspired about a coral and reef area that we did, and she made this beautiful art piece for our vehicle. So what we try and do is we try and have all the artists do something a little bit different each time, so that we can basically have different art pieces on the vehicle, and it just provides a little bit something different.
Nice paintings done from Lily Simonston and other artists that have come on board. So tell us a little bit more about how Sebastian connects to the ship and how you would drive the vehicle.
So, as we've seen before, we have the winch up on top there with the umbilical. So what happens is we actually have a big transformer that's on the ship itself. So we actually put the power or the voltage down that cable. It comes down into the ROV, and in the back, which is difficult to see, but inside the middle of the vehicle there's a big motor which is connected to a hydraulic pump. What that does is that spins really fast, and there's actually an oil in there. So it's a bit like your heart. So it pumps the oil around the circuits, and that allows us then to transmit these oil in these little steel pipes to the thrusters. These thrusters are what allows us to drive around. We've seen this before. It's like this. We have basically two on the aft, in the center, so that allows us to rotate and move laterally side to side. We have two on the top of the vehicle, which allows vertical. So that allows us to come down to the seabed and then recover back up to the surface again. That's all done through hydraulics. And then the rest of the items that we have are all electrical. So we have a little transformer in the center of the vehicle. Kind of hard to see, but it's right in the center here. And that basically allows us to run all the things like cameras, lights, any other science equipment they want to add, because we can actually add quite a bit more than we have on right now. That helps explain a little bit more about how that.
There's so many pieces to Sebastian. How did Sebastian get built? Was it off the shelf, or did you make it yourself?
So Sebastian obviously is a unique machine. It uses a combination of in-house parts, which are designed specifically for our task, and off-the-shelf components. The engineers that on the beach, they would be able to fill you in a bit more about what parts were designed and built. But generally, most of the main components, like the thrusters, they're obviously off the shelf. The arms are off the shelf, but all the other parts, like the frame and the science stuff, is all custom made, and they were all put together in Hayward, over back in the States.
So Russ, I have to ask you, do you have a favorite memory or story you could share about your work with Sebastian since you started?
My favorite mission was actually the smokers. It's like they're big towers that come out of the seabed, and they actually have a hot fluid, sometimes gases, that come in there. And they are actually really tall. They can be up to 30 meters high, sometimes more. I find that it's such an interesting sight when you see all these, they're like trees on the seabed. You have to fly through it, and there's all these different obstacles. That's a really interesting and fun thing to do.
I also love the smokers. There have been so many dives. How many has Sebastian done? And tell us a little bit about some of the cool things that you've been able to accomplish with Sebastian.
We've done over 335 dives. We have done, one of the amazing things that I like about Sebastian is the fact that we can integrate such different technology. Lots of scientists bring things like mass spectrometers, which are very, very unique gas sampling devices. We've actually got the ability to actually mount these and plug them into Sebastian and make them work. Take them right down to the seabed and actually do really, really interesting work at source. We also, just the ability to be able to take different pieces of equipment that are not usually available down to these depths to do science is really what I find amazing.
And so I think that begs the question in terms of how important it is to have a vehicle like Sebastian. What do you think is the most valuable thing about having Sebastian for exploration?
I think Sebastian, the way it's set up, the way we have, it's obviously the beautiful video and the payload factor, the fact that we can store so much stuff on board and get the information back to the public, and the scientists can get all those samples up so they can process them. I think that's one of the main features about Sebastian. It just has such a capability that is so unique and so needed in this world.
I couldn't agree more. The discoveries have been incredible. Thank you so much, Russ. It's been lovely to talk with you, and we'll circle back for some questions afterwards. I would like to shift now across to the west coast of Canada as we're joined by...
Hey, Carly, how you doing? Yeah, no, Sebastian has been a really big challenge for all of us, but really an amazing opportunity to see Sebastian grow from just a blank piece of paper back in July 2015 to conducting over 350 plus dives from around the world. Now, Sebastian's quite a bit different from other vehicles out there because it was designed specifically for science. Russ touched on it a bit there, but the whole frame and everything was really configured to really maximize how much science could be done on each dive. Also, I still have sketches around my house of different arrangements and shapes that I had. And, you know, even one of them I tried to draw the Millennium Falcon from Star Wars to get the general shape. It didn't quite turn out that way because I needed to make sure the weights and balances were correct, but it still turned out pretty well. But life for Sebastian really started 4 years ago today when we first lowered it down into that test tank at Mbari. It was probably one of the most exciting points in my career, but also one of the most stressful, but it turned out okay. So after the test tank and all that, we shipped her off to Guam and we integrated the system onto the research vessel Falkor and then conducted our sea trials and then onto our first science cruise on the back arc of the Marianas Trench. On that very first dive in that cruise, we discovered new hydrothermal vents and live volcanoes, which we actually went down into and actually got caught with an eruption right around us. So the entire bottom end of the frame kind of got covered in molten sulfur, which was quite exciting. And we're still finding bits and pieces of that today. So fast forward 4 years and here we are.
I remember those dives. They were really exciting. And you still go out to sea, but now you do a lot from shore. Tell us a little bit more about your position and what it takes to maintain and upkeep the capacities of an underwater robot.
Yeah, I had my days offshore, and now I've really kind of focused more on the onshore tasks and supporting Sebastian from here. I work with our whole shoreside team to get the equipment, the ship, and the vehicle ready for each science cruise. There's so much that goes into from proposal stage to that very first dive. We even, I think it was last year, we had one cruise that we had to integrate 17 different pieces of equipment onto Sebastian. So part of my role is to make sure that all that stuff gets mounted on the vehicle, the weights and balances are right, any development that needs to be done, me and Nick, the electrical engineer, kind of work together on, and we just make sure that the guys offshore have all the tools they need to have a successful cruise.
And you work with a lot of scientists too to make their research dreams come true by designing and creating all kinds of tools for Sebastian to help them to achieve their goals. And there's been some really, really creative things developed. Can you share a little bit about some of the stuff you've made?
Yeah, sure. The one that jumps out is last year, I was asked to design a meteorite collection device for NASA. They wanted to try and collect these specimens of meteorites off the coast of Oregon. So I kind of brainstormed with a few people from NASA and internally here with some of our engineers and came up with basically it was an industrial sized vacuum cleaner that Sebastian's manipulators would grab onto like handlebars from a motorcycle and drag through the top layer of the seafloor. So that worked quite well. I'm also working with a couple of different groups right now to develop some midwater sampling tools for some of those trickier samples like jellyfish in the midwater. So I'm working with the University of Rhode Island, Harvard, and Mbari on a few other technology developments. Hopefully we're going to test this December.
And for some of our younger friends, we wanted to play a little bit of show and tell here. So I'd love, Jason, if you could share a little bit more about that monster metal thing that you're standing right next to.
Yeah, sure. This is the latest piece of equipment that I've developed for one of the cruises that was supposed to be happening this year. Last year, a PI put in a proposal to study the makeup of a landslide from a subsea volcano and the evolution of the post-event sedimentation. So we needed to get a better sample size, like a core of the landslide. So we couldn't use one of those standard push cores like Russ had shown you. So we needed a sample size that was a little bit more like a 1 to 2 meter core size. Now, my video cut out there. Can everyone hear me okay?
We can hear you, Jason.
Okay. Sorry, I can't see anything on my side. Anyways, yeah. So we needed a 1 to 2 meter type core into a little bit coarser material. And fortunately, Imbari actually had already developed this system called the VibraCore system, and they were really generous to kind of provide the design to me and help me along with the development to kind of modify the design to be able to mount on Sebastian. Now it's about a 350-pound piece or 175 kilograms. So it's the biggest piece of equipment we've mounted on Sebastian. So there was a lot of analysis to make sure the weight and balance is gonna work out okay. So the black part of this whole system is the aluminum frame. That's the structure that can handle the weight and the vibration, and also how it mounts directly to Sebastian. I'm not sure if you can see, but there's a whole bunch of hoses out the back end. There's a lot of hydraulic cylinders that move in here to work, as well as these big hydraulic vibrators that kind of shake the core. So just to show you a little bit, so the manipulator will grab one of these out of a holster on the vehicle and put it in this clamping device. And there's a little plate it sits on here, which then gets opened up. And this whole system is on a winch and a rope, which removes the vibration. It decouples the vibration from the rest of the vehicle. It raises it up and then eventually just vibrates the whole system from the weight and the vibration down into the seafloor. And then once done, it brings it back up and then it hands it off. Sorry, a little loud there. Hands it back off to Sebastian. And hopefully we'll get a chance to use this in the not so distant future.
Excellent. Well, we'll have to use our imaginations a little bit there, Jason. I think your camera froze for a minute, but we can get the gist of what you're talking about. So no problem at all. Now, I'd love to know a little bit more about how Sebastian got its name.
Sorry, is my camera working there now?
Yeah, it's
okay,
back.
Sorry, I guess my low power mode. Yeah, the Sebastian name, it kind of goes along with the same theme as the research vessel Falkor, which was named after the luck dragon from the movie Neverending Story. There's actually a character on there called Bastian, and we just added the sub to the front of it. So that's pretty much as simple as it is.
Cool things. Not only what excites you, but what advice do you have for someone who might be interested in doing something similar as a career?
Well, the best part of my job is that it changes every day. I really couldn't tell you what I'm going to be doing from a month from now, other than I'll be working with an amazing bunch of people at SOI, as well as so many different organizations from around the world, doing the latest technology and new discoveries, new scientific discoveries in the ocean. The biggest thing that I can, as far as advice goes, is to make sure you have fun. You have to enjoy your job. And I really do enjoy my job, and I get to do some really cool stuff. So that's probably my biggest advice, is make sure you're having fun.
That's very good advice. They say it takes a village to raise a child, which certainly seems true these days. And it also seems the case for an ROV. I know you collaborate with a lot of different groups. How do those collaborations work? And is there anyone you want to shout out to?
Yeah, for sure. I really want to give a shout out to Marko Talkovic and the entire Imbari team. Without them, I wouldn't have been able to develop this. They were really generous to provide the original design, which this was based on, and have been helping me along over the last 2 months with answering my endless questions of making sure this has happened. I also want to do a shout out to our incredible team at SOI. We have a great shoreside team, as well as the entire Falkor crew that make sure all these operations happen. And of course, our core ROV team, Russ, Adam, Cody, J-Rod, Chris, and Ben. So I definitely want to shout out to all of them.
Well, thanks, Jason. I'd like to take a few minutes now to answer some questions that have come in online. I think the first thing we would want to say is if you could tell us a little bit about the cantilever system and how the tether stays untangled. Russ, do you want to take that one?
Yep, cantilever system on the aft deck. So basically, what we have on back deck here is an A-frame. This A-frame allows us to, like with the docking head, so what we'll do is we'll use the winch, we'll actually pick up the ROV, and it gets locked into the docking head so that it can't fall out. Then we have a thing called a constant tension device. So we actually press the constant tension. It'll maintain 500 kilograms between the winch and the vehicle. That then allows us to A-frame the vehicle out overboard so that we can then deploy it into the water. So once we get it overboard, obviously we're checking for environmental conditions, making sure that the weather's suitable and the ship's happy. Once everyone's good, we can then take the constant tension off, bring the vehicle up, and then we're ready to deploy. And this is where these floats come into play. So once we have the vehicle in the water, then we can actually swim away a little bit. Then we can put a couple of floats on, and then we can, depending on the water depth, we'll configure these to our needs. But generally, that's exactly how we do it. And then the reverse would happen when we want to bring it back on deck. That's how their launch and recovery works on board the vessel.
Fantastic, thanks, Les. We have another question about maintenance. Jason, are you able to share a little bit more about where Sebastian goes for maintenance when it's not diving in the water?
Yeah, sure, Carly. Really, it depends on where it's located anywhere in the world. And a lot of times, you know, depending on where the Falkor is where Sebastian is. So we usually have to ship all our tools and equipment and parts and spares out to the ship and end up doing it on the ship or in the shipyard that it's currently located at.
Excellent. And another question for you is about the weight. What is needed when there is significant weight distribution or change in weight distribution?
Yeah, I mean, especially with a system like this, the VibraCore, mounting 350 pounds on the front of the vehicle, naturally it will want to tilt forward. But we have a lot of different flotation that we can move around the vehicle, which behind some panels that Russ is pointing at right there, that we can kind of compensate for that. So we shift different pieces of equipment around to make sure the weight and balance is balanced both in air and in the subsea world.
Great, thanks. And Jason, I think you might be frozen there. You should try refreshing your camera. Let's go to Russ for another question about the syntactic foam. Lots of questions about the syntactic foam. Seems to be a miracle material. Tell us a little bit more about how it works.
So the syntactic foam, it actually in air is actually rather heavy. It's actually made up from lots and lots of little glass spheres, and it's encased in it's basically like an epoxy. Think of it like a glue. You actually cast it into a shape that you want. The reason for the circular pieces of glass is that the surface area allows it to provide the buoyancy it needs when it's submerged in the water. So this buoyancy block itself weighs almost as much as the frame. However, in water, it's neutral, and it takes up, and it can actually give a lift. So it's a very interesting piece of equipment. It's extremely heavy. So that's pretty much how it works in that respect. And obviously we have extra syntactic foam that we can add in to give us more buoyancy if things are heavier.
Excellent. And Jason, another question for you. Are the electronics inside the pressure vessels? And for the electronics outside of the pressure vessels, how do you stop them from flooding with water?
Yeah, good question, Carly. There's two big titanium 1 atmosphere cans, which means they're filled with air or just the ambient air around us here. And it's the electronics that can't see oil or water or anything like that. So we protect it inside that air chamber. So it's made out of grade 5 titanium and really thick material. So that's the important bits. But there's a whole bunch of electronics that are outside in these oil-filled junction boxes. And we use a pressure compensated system, which uses a big oil bladder with a spring on it, and it balances the pressure from the seawater inside those junction boxes. So really, the pressure inside those boxes or outside those boxes is balanced. There's only about a 10 psi difference between inside those boxes and the water pressure around it.
Excellent. And this is, I think, my favorite question we've gotten so far. I'll throw this one to Russ. It's from our friend Charisse on Facebook. Why is Sebastian and most other ROVs yellow? Is the Beatles song to blame?
The main reason that they use yellow is because when it's on the surface of the ocean, it's more visible. So it means that if we're in a slightly dark, say you're in the early evening and the light's diminishing, you're able to see it easier. And that's generally why they would go for a yellow color, because it's just easier to see from the vessel.
Excellent. And I'll throw this last question to the both of you. We've gotten a lot of questions about your career paths and how people can become ROV pilots or join the SOI team.
Well, I mean, yeah, I can tell. So, I mean, the SOI team, we have openings periodically on the website, so it's worth checking the careers option for that. From my personal point, I actually been at sea now for over 22 years. I actually started in a slightly different environment, but I've always been involved with subsea machinery. I kind of grew up with engines and cars and mechanical stuff, so I was always involved. But I've got a suggestion. Basically do what you love to do. I mean, I love this. I love this job from day one. I've always loved tinkering and playing with mechanical and electrical equipment. So I would say that, I mean, from a point of view, when you're at school and if you've got an enjoyment in something technical, go for it. Just do what you want to do, because it's so many opportunities, and it's an amazing life to be involved in. Jason?
You got to have fun and really be excited and passionate about what you want to do. I find that the more things I get passionate about, I work harder, I get motivated to do it, and it's usually with stuff I'm interested in. So I've been kind of around mechanical stuff my entire career, right from I was started as a logger and working on hydraulic equipment back in those days, and then I did underwater logging and developed a submarine to cut down trees underwater, and then I eventually moved into the ocean and doing science. So it's been a bit of a roller coaster ride, but I've loved every minute of it, and it's been pretty exciting.
Okay, everybody, I think Carly got frozen here. Oh. Let me see if I can find a question real quick as we get Carly back. We have some questions on Facebook and YouTube.
What we can do is we can flash up the ROV here and we can show them the arms working.
Yeah, okay.
Hey, Chris, let's get the HP on and start getting the arms working.
We're going to give you a little quick demo while Carly comes back to us. Chris is going to come.
I've got you. Without HP in bypass. Yeah, we can do a little check.
Okay.
Okay.
So for everybody at home, Russ, can you tell them what HPU stands for?
So it's basically a hydraulic power unit. Basically, think of it like a pump. So that basically now you can hear the pump running. So the electricity is flowing down that cable, and it's turning a motor. At the same time, it's actually attached to a pump, a little splined shaft, so it connects there. So now that's rotating. You'll actually hear, obviously, the noise. That's the hydraulic oil now pressurizing the whole system. If Chris comes on with the starboard arm, I'll actually show you the arm moving. It would be used for doing sampling. A coral cutter on here for doing. Just
go ahead and do me a favor.
And it's coming live now. So.
So Russ, just keep talking them through what Chris is doing here in the control room.
So Chris is actually, he's actually in the control room right now, and he has a small controller. So whatever he does with the controller is actually doing the same with the arm. So he's actually moving it a bit like you would move your own arm. That way he's mimicking that motion. As he's moving around, he's actually been able to check all the joints. It all works. Jaw here is, this arm actually will be able to hold about 450 kilograms. And it can actually lift that from the seabed. That works out about 1,000 pounds, approximate lift. Both arms are identical. We're just going to move into high pressure now. There we go. Slightly more movement there. See? Looking good. The functions are working well. Hope you're good. If you shoulder up and elbow down. Looking good there. And then we can operate the camera as well. So what we can do as well, this camera, their 4K camera, we've actually got a hydraulic ram on there too. So we can actually move this forward and back. Give us a better view. There you go, you can see it moving in there. And coming back out again. That allows us to actually move the camera if we've any samples that are taking up space on the deck. We can actually move the camera over the top so we don't get any obstructed view. Can we index our suction sampler? Now if we can see our vacuum cleaner here, this is actually our suction sampler. You can see the arm. This actually goes round and attaches to this device here. You get a chance to see that earlier. So if we can index this, these are the jars, so we can actually keep our samples in here. And we can rotate them round. This is the little area where we can actually trap our samples. Yep. And I'll stop there. And if we see how we can see the thruster in the center, we're going to do a little test in our thrusters here to show you it's actually working. There we go. Oh, I can feel the wind there. Okay, and vertical up. And vertical down. Perfect. And if we can do the axials, come ahead. Perfect. And aft. There we go. So that shows you, that's basically how Sebastian will operate and move when she gets down to the depths. When the joystick is moved, it will give a proportional command, allows these thrusters to operate. So when Chris is actually in the control room, we're actually flying, whatever he does on the joystick will actually allow Sebastian to follow that. And we can kill the HPU there. And we're going to do some testing of our lights just now. You can give an idea of the level of light that we have on board. Let's try our boomers first, please. These are extremely bright. There we go. Off. We also have these additional lights. So we've got, these ones are called cathodes. They're really high-powered LED lights. So we're going to try our inner ones first. Oh, that's okay. Ours fine. Ours are good. And inners are good. You can see straight away how much light you actually have. It's so much light is available that you'd never have a problem viewing the seabed. And actually, another thing that we probably didn't touch on is we actually have two sonars. This is actually a digital sonar. This is used. It's very, very high quality imagery for wall work. And obviously, this is our normal sonar. Right in the back there, you can actually see there's a red object. That's actually for location. So when Sebastian is in the water, we need to be able to know where she is in relation to the ship. This beacon or transponder is connected to the actual vehicle, and it transmits a specific channel so that the ship can actually come in and actually determine where that is on the seabed or mid-water, depending on what we're doing at the time.
Russ, we just got a question on Facebook. Why are the thrusters hard plumbed? Is vibration not an issue?
The vibration is an issue with these particular runs. The way they bend the pipe, it actually takes a bit of the shock out. It also allows the hydraulic oil to have cooling. It's one of the things, especially with working in these environments, it's really nice to have that additional cooling. So that allows it's basically if you had a rubber hose on there, for example, you wouldn't have the same cooling capacity.
Yeah, and just to add to that, they are all mounted with basically Stoff clamps to prevent any kind of vibration to shaking them loose.
Exactly.
Awesome. So I think, guys, we've actually run out of time today. I'm going to do our closing statements. Unfortunately, with technical difficulties, sometimes that happens. So I just want to thank everybody for their time today. I want to thank everybody at SOI Shoreside, Carly and Logan, Carol, and the rest of the team who have helped set this up. Those of us on Falcor really appreciate all of the hard work on both sides. Just want to remind everybody that you can join us for all of our ROV dives live on YouTube, Facebook. We are on all of our social media for Instagram.
We do have one last shout out for Sebastian. We've got happy birthday, Sebastian.
Okay, let's move to the right a little bit. Great.
So we made a little cake for Sebastian so he can celebrate his 4-year-old. Oh, and it's gone out. Thank you very much, everyone.
Yeah, thank you.
Thanks, everybody, for joining us. We really appreciate it. You can keep asking questions at schmidtocean.org. And please continue to follow us. Thanks again, everybody, and happy birthday, Sebastian.